So today I will continue with for loops and nesting for loops in here. But first, please remember a basic for loop that we were just adding a vector in here or any condition in here. Then it is going to just run this line of code several times by looping in for loop, okay? But now we will see a nesting loops. That means that we have a for loop which is nested in another loop in here, okay? And then the inner loop is executed in full before the outer loop index is incremented, at which point the inner loop is executed all over again. But I think it is much better to get the idea with a basic example in R for understanding nesting for loops. First, I will generate two vectors. The first one is going to be loop back 1, which is going from 5 to 7. And maybe you want to see that vector. And I have another vector, which is loop back 2. And it's also going from 9 to 6. These are my two loop vectors, and then we will work on them, okay? And after that, I will generate an empty matrix. Then I will fill this matrix with my loop here. Here is my empty matrix, full matrix. And you can easily use matrix command to generate an empty one with NA. And the first length, which is row, is going to be the length of loop vector 1. And second dimension, which is column, is going to be the length of my loop vector 2. And foo, which is not foo 00, foo is going to be something like this one, 3 by 4 matrix with all NAs, okay? Now we will do nested loops fields foo with the result of multiplying each integer in loop vector 1 by each integer in loop vector 2. Okay, let me repeat. I'm going to fill every element in foo by multiplying each integer in loop vector 1 by each integer in loop vector 2. Let's see what I mean. I'm having a for loop first, and the first loop in here is in 1 to length. Let's say loop back 1. Here is my first loop. We will also have another loop which is going from J and 1 to length of my loop back 2 that we already know them. And we will just fill each element of my matrix, and I can index them by using ing. I stands for rows and J stands for columns. And here is what I'm going to get: loop vector 1 and ith element for each step of my outer loop, and then we see loop vector 2 and get the jth element for each loop step or each repeat in here, guys. Okay, here is my loop, and when I just write foo, sorry guys, you see that I'm having a matrix which is filled the result of multiplying each integer in loop vector 1 and loop vector 2. Please note that in here, these nested loop require a unique loop index. You see that the first one is I and the second one is J. They have to be different than each other, okay? So in this case, that loop index I is for the outer loop, and maybe you see that this J in here is for the inner loop in here. And when the code is executed, I is first assigned 1 and the inner loop begins, and then J is assigned as 1. The only command in the inner loop is to take the product of I elements of loop vector 1 and the jth element of loop vector 2, and assign it to row I and column j in here of foo. And the inner loop, this guy, the inner loop just repeats until j reaches the length of that loop vector 2, and it just fills the first row of foo in here. Then I just increments and the inner loop is started up again. The entire procedure is complete after I reaches the length loop vector 1 and the matrix is filled. Maybe we can see it by writing something like, if you just print foo in each step, maybe it's going to be much easier for us to see what is happening inside. I have my foo, it is NA again. Then I'm going to run that nested for loops, and then you will, for each of them, you will see that how it is working. In the first step, we had the first one, then the second one, then the third one, and the fourth one. This is the first inner loop. It's related to E in here, 1, and J is changing from 1 to 4. And for the second step, for the outer loop, we are going to do 2. And again, we will fill by J from 1 to 4. And at the end, you see that we are going I to 3, and then just fill by rows depending on J in here. And I save the file. So I will post an exercise for you guys. Here is my exercise. I want you to rewrite the nested loop example in here, where the matrix foo was filled with the multiples of elements of loop vector 1 and loop vector 2. And you will do it by using only a single for loop. Please remember, we were doing that by nested loops in here. Now you will just use only one. Let me show them all together maybe. I want you to use them and just run this loop by using only a single for loop. Let's just solve the exercise together in here. Please remember, we have two vectors in loop vector 1, loop vector 2, and an empty foo matrix. Now we will again fill this matrix by multiplying the elements of loop vector 1 and loop vector 2, and now we will use single loop in here. I want to use I again. I goes from 1 to length loop vector 1, okay? And inside of this one, you can just use foo, and you can fill your foo by matrix. Just leave that column index as empty one, okay? And now it's going to just fill everything by row, and we can just go and get loop vector 1i for each element and just multiply that one with loop vector 2. That's how it is working. And when we just check out for foo, you see that we have the same result. And if we just run this part, foo is NA, one more time by using print foo, and you see that how it is filling your matrix, and it just fill your matrix for each row in every step. This is much easier and faster, and you can even try this one for you guys. So you can even run the same loop with J elements and in column wise in here, okay? You can fill your matrix row wise. This part is just row wise, okay? Or you can just fill your vector by column wise in here. It's up to you guys, but please make sure that you just add the true length in here in your examples. So I will continue with for loops, and this time let me share my PowerPoint with you guys. I feel like this is more easier way to get the idea for loops in here. I will continue with that while loop. Now we have different options in R or even another languages like Python or Unix, whichever you are using there. And you can use different options for looping your codes in R. And for example, I can just use while in your case, and while has that condition. And if that condition is true, the statement, which is like the code in here, is just repeated or iterated while the condition is true in here. And when it comes here, and if the condition is false, and then you just exit from the loop and get the final result, okay? And here is on the right hand of the screen, here is, you can see how we are just writing a while loop in R. You have while, and again, your parentheses in here. Inside, you have your loop condition, and then you do any code in here for while loop. And this is how we see it in here, and we will move to R together. Let me just see, where is my R? Here. And we will continue with while loop in here. Let me write on my screen and the while for this lecture. So we just use that for loops. If you want to use it, you must know that, or be able to easily calculate the number of times the loop should repeat in here, okay? But in situations where you don't know how many times the desired operations need to be run, you can turn to the while loop. Maybe when we just check out for loops, we know how many times we are going to iterate this code, let's say in here, for loops, but for sometimes we don't know how many times we just loop that desired operations or run that operations in here. And a while loop runs and repeats while a specific condition returns true. Okay, when we write while, we will give a condition, and your code is just, your loop just runs while it returns true and takes the general formulation like this one. I have my while, we already see that one. We have the condition in here, and we can write here anything we want, and it just do any code in here for you guys, okay? And please remember that a while loop uses a single logical valued loop condition to control how many times it repeats. You need to add a single condition in here, and upon execution, the loop condition is evaluated, okay? And if the condition is found to be true, the braced area, this part, guys, is executed line by line as usual until complete. And at which point the loop condition is checked again and again. And the loop terminates only when the condition evaluates to false. And it does so immediately, the braced code is not run one last time. Please keep in mind that. When it just finds the false, it stops there, and this part is not run one more time, okay? Let's see what I mean. Let's see, this part is just a comment for you guys. And I will continue with a real example. I'm going to give you a scalar now, an object or. This is my val or value as 5. And I will just find something while my val is smaller than 5, okay? And I'm adding something like counter, and my val plus 1. And here is my cat function. And we are writing something like, let's see, my wall is now what is my wall, and we are moving to the next line. And after that, I'm adding another cat function here, guys, to print something on my output. My condition is now, let's see, what will I know? My wall smaller than 10. Here is my condition. And we are moving to the next line. Okay. Here is my wall value, which is 5. And while this condition is true, R is going to run this part, and when it finds, sorry guys, this is going to be 10, okay? We are looking for my value smaller than 10 in here. And here is my wall. And then what happened? I forget something. My condition is now true. What happened? What happened? What happened?
I think line 49. There's a
I forget something.
slash. It is the slash between before the end.
Sure. Thank you. So I have to add something like this one, guys. Okay. Let me just add this one too. Maybe it will seems much better for your review. Thank you for the warning. And here is how. And this is my value as 5. And here is my condition. It's going and checking for this one. First of all, my value is 5 and the condition is true. And now my value is 6 and here is cat. My value is now 6 and my condition is now true. And after that, my value is 6 and condition is true. And in this part, my value is 7 and it's going to write my value as 7 and my condition is true. And it repeats like 4 times. And when it is something like 9 and the condition is true, my value is 10 now. And it's going to go and write this part. And after that, it goes and just check out for 11 or 10, I mean. And then the condition is false and it stops there. It never runs it one more time in here. And I will give you some more examples, guys. And in more complicated settings, if you have like a more complicated setting in here, it may be useful to set the loop condition to be a separate object so that you can modify it as necessary within the braced area in here, okay? And now we will use a while loop to iterate through an integer vector and create an identity matrix with the dimension matching the current integer in here, okay? And we will stop the condition when it reaches a number in the vector that's greater than 5 or when it reaches the end of the integer vector. Let's see what I mean. So we will just write another while loop, guys, but we will set the loop condition as a separate object in here. First of all, I'm going to generate a list, an empty one. Here is my empty list, okay? My list. And we have a counter as 1. And we have some numbers, which are my numbers. My numbers. And let's see, 4, 5, 1, 2, 6. 2, 4, 6, 6, 2. Okay, here is my numbers, which is a vector, and I'm adding my condition outer in the outer of that while loop. I'm not adding inside it. I'm going to just define my condition separately, okay, as an object. Let's see, my numbers, I'm getting one of them by indexing with counter and smaller than 5. Here is my condition, guys, okay? I'm looking for my numbers, and for each counter, let's say the first one is going to be 1, and what is going to be this one? if I run this part right now, the answer is going to be true. The reason is that my counter is 1, okay? And when I check here, my number 1 is just 4, the first one. And since 4 is smaller than 5, the answer is going to be true for this case, okay? This is my condition. And it is going to check it for each of them. I want them to check for each element in my numbers. And for this one, we can just write a loop here. Let's see how can we generate the loop by using while. Of course, you can always use different types. And while my condition in here, sorry guys, condition is obvious. If my number, any of them is smaller than 5, I am doing what? I'm just filling my list elements by counter, okay? And as the diagonal of what? My numbers, the element counter. I'm generating a diagonal matrix by using the elements corresponding to that counter. And we are just increasing our counter inside, counter +1, okay? And that is how your loop is running. You adding, doing that increment in this step. And I also want to add an if statement inside. Let's see what's happening. If, again, something, if but. If counter is smaller than the length of my numbers, which is my vector in here, okay? What is happening? My condition now, I'm just changing my condition as my numbers counter 5. And we have an else now. If not, my condition is just false, then it stops there. Okay. So guys, we are just checking for the condition for each step. And if it is true, my list element is going to be diagonal of the number. It can be 4 or 5 or 1 or 2, not 6, 2, 4, not 6 in here, okay? And then doing that incrementation of my counter at this step. And I'm also looking for the length of my numbers. If that counter is smaller or equals to length of my numbers, the condition is the same. I mean, it has to be same, guys. Smaller than 5 in here. And if not, my condition is going to be false. And for the next step, it's going to there, and my condition is going to be false in here. Let's start over. Counter, my number, my condition, and in here, I can see my list as a list from the matrices in here, and it is just running. And let me just talk about it, okay? Let me just talk about in here. The loop condition, my condition in here is, guys, is initially set to true since the first element of my number is less than or equal to 5, because it is 4, okay? Inside the loop beginning at while, the first line uses double square brackets and the value of counter to dynamically create a new entry at that position in my list, guys, okay? It's just dynamically generating a new position. This entry is assigned an identity matrix by using diagonal, okay? It's going to be an identity matrix in here whose size matches the corresponding element of my numbers, okay? For example, if it is 4, I have 4 by 4 diagonal matrix in here. Next, the counter is incremented, and now you have to update my condition. Here you want to check whether my number counter 5, but you also need to check whether you have reached the end of the integer vector, okay? If you didn't check for this one, guys, if you don't have this if statement, you can end up with an error by trying to retrieve an index position outside the range of my numbers in here. So you can use an if statement to first check the condition counter is smaller than the length of my numbers. If your counter is smaller than the length, and if true, then set my condition to the outcome of my numbers counter smaller than 5, the same one in here. If not, this means you have reached the end of my numbers. So you make sure the loop exists by setting my condition as false in here, guys. Okay, let me run that one more time and see the output. And we are going to have like 1, 2, 3, 4. Like, let's see how many metrics in here in my list. And for each of them, we are having that diagonal matrices in here. And when it finds that 6, it stops there and didn't run the rest of them, okay? It stops in here because 6 is greater than 5, and while condition is false, and your loop stops and does not iterate anymore in here. So now we talk about break or next. And so in our programming, a normal looping sequence can be altered using the break or the next statement in here, okay? And please keep in mind that a break statement is used inside a loop. Like you may have repeat, for, or while, then we can use that break inside our loops in here, guys, okay? And if you want to stop here, stop the iterations and flow the control outside of loop, we can use a break inside our loop in here. Let's see what I mean. Maybe it's going to be much easier for us. I'm generating a vector first, the x vector from 1 to 5. And for, let's see, value, val in x in here. I'm doing if statement, adding an if statement in here. If that val equals to 3, break, okay. Otherwise, just print val in here. Okie dokie. Here is my for statement. I have an x vector from 1 to 5. I'm checking a value in x, and if that value is 3, I break. Otherwise, I print val in here. Here's what we have: 1 and 2, and when it comes to 3, it just stops there and doesn't go to the next iteration. Okay, and break is kind of easy to use. It's like the meaning of the break. And we also have next statement, which is also useful when we want to skip the current iteration of a loop without terminating it. Please keep in mind that when you use break, your loop just terminated just there, okay? But you can also just skip one of the values without terminating your loop in here. And on encountering next, the R parser skips further evaluation and starts next iteration of the loop. Let's see what I mean. Now in here, I have the same code chunk. Let me write it in here. I have my x from 1 to 5. I'm going from value in for each x and checking for this condition. And if it is true, just go to the next one. Okay. If the value is equals to true, go to the next one. Here is what's happening. 1 and 2, and when it comes to 3 in x, I just next to the next line, and it is printing 4 and 5 for me, guys. I think it's kind of easy to use in here. So we covered while loops. Now I'm moving to repeat statements. It is kind of similar. It's another way to looping in here. And we are repeating something inside that curly brace in here, okay? And I have my condition, and it is just iterating that condition. And when it is true, I think I just false has to be here maybe, and the condition is to repeat if. Okay, this is kind of working differently in here. And when my condition is false, it's just iterating, and when it is true, it just break your iteration in here. Maybe the example is more helpful for us in here, guys. Let's see how it is working in R together. I'm moving to repeat statement, and this is another option, of course, for repeating a set of operations in here. And the general definition is simple. Let's see, we already see it. I'm just writing repeat, and here's what. Oh my God. I have this one, and do any code in here. And in here, a repeat loop is used to iterate over a block of code multiple number of times, okay? So there is no condition check in repeat loop to exit the loop, but we must ourselves put a condition explicitly inside the body of the loop, okay? And use the break statement to exit the loop. So when you run the repeat, it just repeats the number of times you gave it, or it repeats the number of times until it sees the break statement inside the loop in here, okay? Please make sure that if you do not add any like stopping condition in there, like break, the result will go into an infinite loop in there, guys, okay? Let's see what I mean. And here is what. I have a scalar x as x equals to 1. I'm going to repeat something. I will repeat printing x, and then I have x equals x to 1. And if something, if my x is equal to 6, I just break that, okay? Kind of different in here. I have my x as 1. I'm going to print everything. When it is equals to 6 in here, and it just break and stop printing what was happening inside in here, guys, okay? And I just want to show you something that we can compare everything together as a general sense in this example. We start with for loops and we initialize it and we check out the code block. And for loop is just checking for if it is in the last iteration. If not, then it just continue to do your code block and just iterates between inside that code block, okay? And if it just reaches to last iteration, then terminates and give the results. And for while loop, we are just checking for a logical condition, and then until it is false, it's just running that code block when my logical condition is true. And the logical condition is, when the logical condition is false, then it is terminating your loop and stop there, okay? And then we have another repeating sentences or looping sentences, which is repeat. We have code block. When it is false, it's checking for the logical condition. And when it is true, it just terminates everything, okay? And here is how our codes are working. And let me just share my studio with you guys. So we will continue with data cleaning now. Data cleaning means identifying problems caused by data collection, data processing, and storage process, and modifying your data. Okay, so if you want to clean that part, then the problem don't interfere with our analysis in here. One of the problems can be your duplicates in your data sets. Okay, data sources often may include some duplicate values in here. Depending on how you plan to use the data, the duplicates might cause some problems, guys, okay? And maybe it's a good idea before starting your analysis. It may be a good idea to check for duplicates in your data if they aren't supposed to be there, okay? Let's say I have an example. My example, I have a vector now, and which are Newton, Darwin, I have Tesla, and Faraday, and Graham, and Newton again. Let's say in my example vector, this Newton is there twice accidentally, okay? I didn't mean it, but suppose you accidentally included one name twice in here, which is Newton, okay? You can easily apply duplicated function to your data frame. Let's say how we can use it. I have my duplicated function defined in R. I can just use it in my example, and it shows you which one is duplicated. Sorry, guys. And this one is duplicated, and this is the second Newton. And Newton, it just show you where. And you can use the resulting vector to remove this duplicate. Let's see what I mean. I want to generate another my example, and maybe I can give it a name, something like unique. And here is what I can just say my example, and then I want to index that one by getting the ones which are not duplicated, okay? Which are not duplicated in here. And if you want to check out my example unique, and you see that you only have one Newton now in here. Alternatively, you could use the unique function to remove the duplicate values in here. Here is how I can use that one. My example, unique, maybe 2 in here. You can just use unique, my example, and then it's going to just give you the ones which are not duplicated and just give you the unique ones in here, guys. That's kind of easy to use, okay? So I want to give you also some example in sorting. To sort a data frame, you need to create a permutation of the indices from the data frame and use them to fetch the rows of the data frame in the correct order, guys, okay? And I assume that you already know sort function, and today we will use order function, takes a set of vectors as arguments in here. And it sorts recursively by each vector, breaking the ties by looking at the successive vectors in the argument list in here. And at the end, it returns a permutation of the indices of the vector corresponding to the sorted order in here, guys. Let's see what I mean. I have a vector, something like V, and I'm combining some numbers, 11, 12, 13. You may type with me, 14, 17, 16, and 15. If you want to sort this guy, you can easily say order V, and you see that order is just giving you the places or indices of that guys in here, okay? It just returns that indices of the vector corresponding to the sorted order. Here is our sorted order in here, guys. And you can just use that one to index your V vector. Like here, sorry guys, we have to add V in here. And then you see that you just sorted your vector by using order function in here, okay? And this is going to be much helpful. Maybe for a vector, it's kind of easy to sort by using sort function, but maybe we can use that one for a data frame, which can be much easier for us, guys, okay? Suppose that we just generated the following vector again. Here's my U vector. And I have some character values or strings in here. B, let's say I have bird, cat, dog, cow, camel, and elephant. Here are my elements of my vector. I want to combine them, guys, and to generate a data frame. And here is what we have: U and V together. And when you write W, you see that you have U as a character vector and V as a numeric, okay? And then we have W data frame. And we can just use, or we can just sort the data frame W by V using the following expression in here. I have my V data frame. I'm going to use the vectors of this data, the rows of this data frame, and I want to order that V depending on W depending on V in here. And we are going to use that order. Here is my order from my V, 1, 2, 3, 4, 7, 6, 5. You see that part from V. And then we use these indices to order the rows of my V. And when I run this one, you see that it just orders everything depending on that one, guys. And it's kind of easy to order. Let me also give you another example in here. We are going to use another data set from the library of, let's say, SDAA. Okay, here is our library. And we will use that data authors. Here is the data. We can just see the first 6 lines and just check out what's happening. Here is the authors data set. It has 3 columns, that means 3 variables, which are section, habitat, and holds in here. You can easily sort by habitat and then by holds for authors data set in this SDAA library using order function, okay? Keep in mind that I want to sort by habitat and then by holds in here. And we can use something like this one, guys. I have my authors data sets. I'm going to index that one. I will order that one by rows, okay? And that ordering is going to be first, the first variable, which is authors habitat. And then we have the same data sets again with different value. Okay, now we sort by habitat and then by holds in this example. And you see that in your data, your habitat is sorted first. And for each level of that category, you see that your holds are sorted inside that one. Okay, we have 2 steps in here. And this is how it was working for this example. And because sorting a whole data frame is a little strange in here, let's see. When I say order authors in here, you see that it's kind of weird in here. It doesn't make sense to me. We just can create a suitable permutation using that order function instead of using that directly. And we can also use that do call function to work it properly in here, okay? Please keep in mind that order expects a list of vectors and interprets the data frame as a single vector, okay? Order is working with a vector, guys. So when you just give a data frame to an order function, it is interpreting your data frame as a single vector, not as a list of vectors in here. So order author is not working for us. It doesn't make sense. Our data frame is interpreted as a vector. Now we can just use do call in here and see what is happening. I am adding do call in this example. Order is the function for you, for your information. Order is the function, and please just apply this function for this data set. Okay, here is do call, and it's going to give you some indices, guys, in here, and then you can just use it to index your data set. Authors is my data set. I'm using that guy, and do dot call, and for each rows, and I'm using order for authors data sets. Here is what it is, just ordering everything this time for my data set by section in here. This is how I am ordering my data sets in here, guys. Okay. Actually, for today, we continue with these for loops, and we use that nesting for loops first, and we see while loops and repeat statement. They are all like looping, and then we see that we can use break and next inside our loops in here. And at the end of the lecture, we just covered data cleaning, and we find and remove duplicates, and then we also sort our data set for today.